Yeah, so I'm going to talk about rtables. Specifically, I'm going to talk about the experience of bringing rtables to production at a company other than the one that it was developed at and is currently maintained by, which would be Roche. So first, a little bit of motivation. There are lots of tables that you need if you're in the pharma space, right? Every clinical trial has dozens of tables that you're going to need to make in order to give them to the regulatory authorities so that you can hopefully, have your molecule approved and get help to patients, right? So, that's a relatively easy problem. A table is a table, right? And we've been hiring more R developers. So we'll just have the clinical trial team make the tables, right? It sounds kind of simple, but that's not really how it works. One does not simply make the tables, right? Like it's a very large and complex problem. And in fact, it's not even an atomic problem, which is what I'm going to talk about right now. So if you think about, I need to create a selection of tables that are going to go together into a clinical filing, for example. There are a number of different levels at which you need to work in order to do that. The first and sort of frontline one is you need someone that's going to actually create the physical tables that are going to be put in the submission, right? And then you have, on top of that, you have sort of statistical and business logic that are constant in your organization across tables. And then underneath that, you have to have some sort of set of tools that can actually construct the tables from your data, right? And so for the individual customization, this is going to be people on your trial teams. They are the ones that know the exact table variants that clinical trial needs. And that's going to vary at least a little bit, sometimes a lot, between different clinical trials, even in the same organization. They are going to use the business logic layer and the core framework in order to define and create these individual tables. And these are going to be specific often to individual trials, but if not, they're going to be specific to a group or a disease area, typically within an organization. And then sort of below that, you have the statistical and business logic. And this is going to implement patterns that apply across many table shells. The spec of a table is called a shell. And that's going to include the statistical methodological choices that the organization has decided to use. And it's also going to include various sort of specific table structures. And this is often going to be developed by a dedicated team that's different from the individuals that are on individual trial teams. And the purpose of this is to ensure that all sort of standard company shells can be created when you combine this with whatever core framework you're using. And unfortunately, this tends to be highly specific to the company. It would be really nice if everyone used tables that look the same, but they don't at all. So this is where we are currently. There's a little bit of movement in terms of the FDA publishing some guidance for certain types of tables, but for a lot of other tables, it's still sort of whatever the company thinks is the best way. And then you have the core table framework, and that is going to be the building blocks that are going to be used by the implementations of the stat and business logic. And this specifically is not specific to any kind of table. It doesn't even need to be, and typically won't be, specific to pharma tables. It will be just, you take data and you make a table out of it. So I'm going to talk about 3 different situations where these sort of 3 layers can interact. And we'll talk about the implications of that as in terms of deploying our tables to J&J a little bit later in the talk. So first is what I'm calling the Wild West, where you have a sort of very low-level general framework. For example, sort of pure GT, where it's like you calculate all the values, give the values to GT, GT renders them into a rectangle, essentially. And there are things that can go on top of GT, but like GT itself, that's really all it does, right? And then you also don't have much in terms of the business logic. Say you're just adopting R, you don't have a team in place that's developing these things. So really, everything is being done by these frontline, analysts on the trial teams. And so what you'll notice here is, there's not a lot of shared work. Each table is taking a lot of individual work, which is the red there. And it can't really leverage things that were done for other tables, even ones that are like closely related. So this is, I would argue, pretty obviously not ideal. But the one that's a little less clear why it's not ideal is the second one, where you sort of have robust business logic tooling, but still a very low level core framework. And so what this is going to do is you're going to have a team that's sort of supporting and enabling the clinical trial analysts. So they have reusable tools that are, this teal or cyan, I guess, that can potentially even generate different related tables, right? So you see that with the branching over here. And so this looks pretty good at first blush, right? Like you've got reusable work, and things are looking nice. And then the last one, which I'm going to argue for, is where you have a powerful core framework that underlies things. And it allows the business logic layer to be thinner without forcing that work onto the individual analysts. And so you can see here, like this, the most of the work is in the shared category rather than being in the table-specific or even table category-specific category. So, but the issue with the second thing that we had is there are always going to be ad hoc tables. There are always going to be some clinical trial that's like, we need a table that doesn't look like anybody else's table for reasons, right? And we have to support that because at the end of the day, getting the submission done is what's important. And if that's the table they need, then that's the table that needs to get created, right? So in the Wild West, it's not really that much worse than it was before because the red lines were already pretty long. Here is where we really run into things, right? Where if you have an ad hoc need, your business logic framework isn't going to address it, or at least is not going to address it completely. And that's where we see now they have to go all the way down to the really low-level core framework in order to get their ad hoc tables. And that requires a different skill set that typically wouldn't be necessary in the frontline analysts, and it's a lot of extra work in sort of per table that they're creating. But if your core framework is powerful enough, it can rise, it can be the tide that rises all the ships, right? Because they still have to start from where the core framework ends and go off and do their own thing, but that path is much shorter than it would have otherwise been. So now we're going to get to the last part of the talk, which is, getting our tables in place at J&J, which again is not the company at which it was developed, and it's not the company that currently maintains it. So the first thing that we have to deal with is, well, we work here, and it was made over there, right? And over there is scary, and over here is nice. And this is very common across basically all industries, right? There's a name for it even. It's not invented here syndrome, right? And you basically have to overcome that. And to overcome that, you essentially have to have buy-in from management. That's essentially the only way to do it. Because if management thinks like this, you're done, essentially. And I've been very fortunate that the management in TechSol at J&J has not fallen prey to this. And the other barrier, which is almost equally pernicious, is tiny changes, right? Like tiny differences in shells that can sometimes lead people to say, well, we can't use that tool because I want a comma and it has a dash. And my spec says that it should be a comma, so I can't have a dash. Therefore, we can't use that function at all, right? And that, if you program in a certain way, that actually can be the case. But if you have a flexible enough core framework, which rtables is, you can actually get around that. And you just have to sort of make people aware of that and have them have the trust in order to let you do that. And so one of the major takeaways here is that before I was talking within a single organization, but essentially the same thing can be true across organizations, right? The business logic is going to be organizationally specific, but there's no reason for the core framework to be. All the core framework does is generate these rectangles on paper or on your screen, but usually on paper, because that's what filings are actually like, apparently. And so Roche has Turn and Chevron, which are part of the NEST project, and that implements their business logic and statistical standards. And some of those matched what we needed, and some of them didn't. And so for the ones that didn't, we developed Junko. And we also use some turn functions in our production templates. So you can mix and match even. It doesn't even have to be a complete split like it's pictured here, but it can be, and you can still utilize the sort of core framework. But there were some barriers. There were some sort of features that J&J wanted that Roche didn't care about because they didn't use. And those ended up being a combination of things that we contributed back to the NEST project so that they're available for everyone, and things that we implemented in our own now open source package called Junko, which is essentially a sister package to Turn. So I'm going to very briefly talk about what these contributions were, and then very briefly talk about what Junko does, and then we'll wrap up. So the major, there was a number of bug fixes and stuff too, but the major things are true type font support, including both word wrapping and pagination calculation, higher order column counts. So if you have sort of nested splitting in your column space, you can attach column counts to any of the levels now. You couldn't do that before. Guaranteed pathability in row space, which is sort of a technical one, which was important, but I don't have time to explain why it was important. And sort of a different rounding spec, because rtables by default follows the IEEE standard for rounding, which is nearest even because of how arithmetic works in computers. But the spec that J&J wanted was the sort of elementary school nearest value, like 0.5 goes to 1 and things like that. So we supported, that's now an option. You can choose either one in rtables and the things that live under rtables more specifically. And then, again, there were other things too that just don't really fit in this talk here. The major features of Junko, probably the flashiest one is that J&J uses RTFs for submission, whereas Roche uses ASCII text. So Roche didn't have like a robust production-ready RTF exporter, and we needed one. And so that we are going to contribute it back to rtables, but right now it lives in Junko, and so we're using that, and it works for us. The statistical and business logic, where it differed from what was in Turn, we put that in there. And some of that is sort of subtly different, but still valid statistical choices. And other parts were sort of structural differences, like the J&J tables tend to have spanning headers, where Roche doesn't. And finally, there was some of the FDA sort of feedback that I talked about before about somewhat standardizing tables is this concept of risk difference columns for a lot of the adverse event tables. And Turn has an approach for that, but it wasn't robust enough for what we needed. So we have a different approach that we built our functions around. And so that's essentially it. I want to thank the people at J&J, both the sort of mid-level management and the team that I worked with directly. And finally, I will leave you with this.